This training will cover some image enhancement techniques, as well as regions of interest and basic data analysis tools included in FLIR Research Studio version 3.0 or later. Here I have the saved data set. This is a soldering iron that will watch cooling down. You can see that I've used super framing. This means there are multiple temperature ranges combined into a single file so that I'm able to measure temperatures from room temperature exceeding 300 degrees Celsius. One of the first things we might want to look at is just improving the quality of this image. Grayscale is very often one of the best ways to visualize your data, but it's worth investigating other palettes. If you click on the palette toolbar and hover over each different tool palette, you will see how the different colors will look on your image. Again, none of this is changing the data itself. This is just a lookup table that's applying false color to the image. While these rainbow palettes may look a little trippy, these can actually be quite good for detecting subtle differences in temperature. For example, when choosing the double rainbow, now I can see the very slight gradations along the base of the soldering iron that were not obvious when looking with grayscale. There are also some palettes at the bottom that will highlight excessive areas. This is similar to segmentation or isotherms, which you can set up yourself. These palettes are just kind of custom made. If you have custom palettes from previous versions of software or that someone has shared with you, you can load these into the palettes folder for FLIR Research Studio in Windows, and they will also appear under user palettes in the software. For now, I'll stick to the grayscale image. Regions of interest are one of the many ways we use to analyze data within an image. You can see all of the region of interest functions available in the toolbar. There's a single point, a 3x3 point, a line, an ellipse, a rectangle, and many other polygon and freehand drawing options. For now, let's start with a basic line. If I draw this along the base of the soldering iron, we'll see that I have a tooltip that shows me the name and the average value along that line. I also see a red indicator and a blue indicator for the hottest and coldest points along my region of interest, which is the line. You can adjust these parameters under the gear wheel, application settings, and ROIs. You can change the label size, the opacity of the text box, and then which indicators and statistics you want to be shown. If you have a lot of regions of interest, it may be useful to turn off the labels entirely, or you can alternate the positions of them from the top to the bottom, left, and right side of the image. If you want to label this something more meaningful to your target, you can click the pencil icon next to the region of interest and rename this to base. Now you'll see that the title has been updated. This can be very useful whenever you use the statistics module under table-based analysis. Now we know which statistics row corresponds to which region of interest. Let me add another one here for the tip. You can also change colors and use the emissivity calculator, which we'll cover in the next video. Another important analysis tool are the line plot functions. Let's do a line plot along region of interest 1. I'll place this in the frame over top of the statistics data set. We can still switch back to statistics by selecting it from the drop-down. Here you can see a profile plot along this region of interest line. This is only for this single frame of data. As I step through the data frame by frame, you'll see the profile of the line change. If I play the video, it will also update the line profile plot along with the video. Let's say I want to look at this temperature as a function of time. In that case, we'll use a temporal plot. When I click the temporal plot, I'll select the region of interest, and then it will ask if I'm looking for the maximum temperature or the average temperature. In this case, let's look at the maximum temperature. Again, I'll put this over top of the existing data set, but I can always return to a previous plot by selecting it from the drop-down or adding it to another frame. Now we're seeing just a small sliver of time while the video plays back. If I want to see more, I can adjust the time sliders at the bottom. If I want to see the whole video span, I can click the Fit and Span tool. If I want to go back to follow mode, I can click the follow icon. If you make any changes to the region of interest, you'll want to rebuild the plot so that it includes any updated information. If you want to share this plot, you can export as either an image to put in your PowerPoint presentation or as a CSV if you'd like to rebuild the graph. In this case, we have multiple lines, so we may want to overlay the two plots. I'll again do a temporal plot for the tip, and I'll click Merge into Current Module. Then I'll rebuild the file, and we see both overlays on the same graph.